Hi, I'm Dr. Jillian Wendt of the University of the District of Columbia. Welcome to the video entitled The 5E Instructional Approach to Science Teaching and Learning. In this module, we will discuss the science learning cycle, also known as the 5E learning cycle. The 5E learning cycle is composed of the following phases: the engagement phase, exploration phase, explanation phase, elaboration phase, and evaluation phase. Let's talk about each. The engagement phase can be thought of as the invitation to students to think. In other words, this is the phase in which students engage their prior knowledge. This is also the phase where teachers provide the hook, or in other words, draw students into the lesson and entice students to be interested and want to learn about the topic at hand. The next phase is the exploration phase. This phase involves the manipulation of materials and student interaction, as students explore scientific concepts and search for evidence and support. The next phase is the explanation phase. In this phase, the teacher interacts with students to assist students in developing explanations based on evidence, thus enabling a deeper exploration of the thinking process. The fourth phase is the elaboration phase. In this phase, the teacher assists students in making connections between prior knowledge, students' personal lives, and the science concept. Thus, in this phase, students construct new ideas. The final phase of the 5E learning cycle is the evaluation phase. In this phase, the teacher and students answer the following questions. What do students know? What can students do? And key to this phase are opportunities for self-reflection and self-assessment. As you begin working on this week's assignments, especially your active inquiry lesson plan, consider how you can utilize the 5E approach or science learning cycle to actively engage students in the questioning and investigating process. It is recommended that you review the active inquiry and introduction article again in light of your understanding of the 5E approach. Can you identify where the 5 E's are utilized in the example given in the article? And how can you directly apply this to your own lesson plan? Let's take a look at an example of the application of both inquiry and the 5E approach. Consider Stigl, Danny, Helfrich, and Sickles' article in the October 2015 edition of NSTA's Science Scope, entitled Using Observations of Fossils to Reconstruct Ancient Environments. In this article, the authors focus on the next generation science standards for middle school earth science, specifically the MS-ESS1 standard and the MS-ESS1 through 4 performance expectations. The standard, as you note on your screen, is Earth's place in the universe, and the performance expectation, as you note on your screen, is to construct a scientific explanation based on evidence from rock strata for how the geological timescale is used to organize Earth's 4.6 billion year old history. This is a table that is modified from the Stigl et al. 2015 article. We'll see the example lesson broken down by dimensions of the next generation science standards and the related tasks. For instance, science and education practices, such as analyzing and interpreting data and engaging in argument from evidence. Disciplinary core ideas, such as the geologic timescale interpreted from rock strata, provides a way to organize Earth's history. Analyses of rock strata and the fossil record provide only relative dates, not an absolute scale. And of course, cross-cutting concepts such as patterns and cause and effect. If we look in the column marked matching student task or question taken directly from the activity, as we go through this activity, you'll see how each of these dimensions of the next generation science standards align specifically with what the students are being asked to do. So let's go ahead and take a look at the actual lesson. The authors developed the lesson in a way that utilizes both the 5E approach and integrates scientific inquiry with literacy skills, while, as they state, leveraging the local fossil record to promote engagement through place-based inquiry. Note that the authors are referring to the 450 million-year-old fossil record of the Cincinnati, Ohio region. The authors also note that a real set of fossils could be utilized to implement this lesson, as could 3D printed fossils or even textbook images. The overarching goal of this lesson is to answer the question, how do scientists use observational data to make inferences about past conditions on Earth? The core goals, as stated by the authors, are to enable students to make observations of anatomical features, demonstrate how fossil preservation provides specific biological information, demonstrate that organisms inhabiting the same environment can change over time, and demonstrate that environments shift their location on Earth's surface through time as a result of Earth system processes. Note that this lesson is deemed appropriate for the middle school learners, specifically grades 6 through 8. The prior knowledge that students need is noted as knowledge of fossils and how fossils form, how the presence and location of fossil types indicates the order in which rock layers were formed, and how to observe, make inferences, and generate evidence-based explanations. For the first E, engage, teachers might tell students that they are going to spend the day being a paleontologist. You should note that the entire lesson or unit is actually a 3-day lesson, yet can be modified to fit your schedule. Teachers might ask, what is a paleontologist? And what does a paleontologist do? This is a great opportunity to explore students' preconceptions and possible misconceptions, and to provide an accurate description of the vital job that paleontologists do. As the authors note, most often students might reply with something along the lines of, they dig up dinosaur bones. You might then ask students if there are other types of fossils besides bones, and if so, what types are there, and where and how might they be collected? Students are then broken into groups where they complete a think, pair, share activity. Individually, they think about and write down as many types of fossils that they can think of in 2 to 3 minutes. They then pair up and share their list with their group members. Then groups share with other groups, thus facilitating discourse and engaging students in the content for the day. A list can then be generated for the whole class on the board, thus giving the teacher an avenue for assessing prior knowledge and addressing preconceptions. Note what the most common answers were and ask students to present ideas about how to group the organisms on the overall list. As the authors note, students will typically focus on vertebrate fossils, at which point you might ask students to consider the modern world and to consider the following questions. Are most of the organisms that they see on a daily basis large vertebrates? And does this compiled list accurately reflect the diversity of life on Earth in the past? Ask students to research the most common types of fossils found in your particular location. A helpful website that the authors share is on your screen. The authors suggest having students summarize what they found thus far in their science notebooks, or having students complete some sort of quick formative assessment. You might consider utilizing an exit ticket as a quick wrap-up. For day 2, or the explore phase, students are next asked to explore fossils, whether real, 3D, or images of fossils, in groups. The authors suggest that the teacher creates fossil sets that include 4 to 6 different types of fossils that are common to your particular location. Once the fossil sets are created, teachers can construct a fossil identification handout for students to use. The handout might be organized like a table with the names and an image of the fossil, with room for students to document. For a more detailed example, you are encouraged to download the Stigall article or visit the online version through NSTA's portal to view the online supplementary resources that NSTA provides. Once the fossil sets and handouts are provided to students, teachers should explain that the first thing that paleontologists do after collecting fossils is to carefully observe and describe the fossils. Paleontologists use great detail to do this, and then they share this information with others. Teachers should ask students to examine the fossils in their set and categorize them according to the types of organisms on their handouts. Assist students as they do this and encourage discourse and discussion. Instruct students to write a pair of sentences in each box on their handout that explains the key features of that type of organism and how to distinguish it as a member of its group rather than another group. Now, moving along to the explain phase, ask each group of students to hypothesize what environment these organisms inhabited when they were alive. Each group should be asked to generate a claim and provide supporting evidence. The authors suggest using the following questions. In what environment did these animals live? How do you know? And on what do you base your answer? Once students generate their claims, a whole class discussion should be convened and a list of hypotheses written on the board. A class discussion can then be facilitated in which each group of students presents and evaluates their claims and their evidence. Here, it is important to note that the focus should be on observations and inferences, or more descriptively, evidence-based claims. Fossils can be compared and contrasted with one another, as well as with organisms that are living today. Specifically, the habitat preferences of the fossil organisms can be discussed based on uniformitarianism, the process by which the habitat requirement of the fossils are inferred based on similarity and differences to modern animals. At this point, the concept of the geologic record or timescale can be introduced with the premise that the use of fossil evidence can help provide relative dates. Students should be asked to consider how the relative age of rock layers can be assessed based on fossil content. And students can then provide summarizing statements in a whole class discussion. For the elaborate phase, students are asked to generate an explanation of uniformitarianism through examining larger sets of observations of the geologic record. Additionally, students are asked to discuss Earth system processes that cause dynamic changes in the Earth's surface. The author suggests for the elaborate phase that teachers use fossiliferous rocks from another interval in Earth's history and note that images of these rocks are fine. Examples of particularly noteworthy fossils can be found on the website provided previously and might include limestone deposits, carboniferous coal beds, or even sandstones. Students should be asked to consider the following questions. Does the same environment exist today, and why or why not? And should be led through a discussion about the impacts of plate tectonics, paleoplate locations, global climate, and global sea level. The authors suggest concluding the discussion with specific examples of how students acted like paleontologists throughout this discussion. I would suggest using the practices for K-12 science teaching or science and engineering practices as a specific guide. For the evaluate phase, a summative assessment utilizing a literacy component is suggested. The author suggests asking students to explain in detailed writing what the ecosystem of the region might have looked like at a specific time in the geologic past. Student choice can be provided here, as well as differentiation, such as by giving students the freedom to select an ancient ecosystem from a list provided by the teacher, rather than the teacher assigning a particular ecosystem his or herself. Students might also choose how they want to present their information. In summary, you are invited to further explore the Stigall et al. Article, as well as other NSTA articles that highlight the 5E approach. It is my hope that through examination of this example lesson plan, you will have a better understanding of how inquiry and the 5E approach can be applied to the middle school science classroom in light of the next generation science standards.